Hi, okay, welcome to session 7. You can see, obviously, there's no recap. The consolidation, I think, is quite intense, and we have done a good amount of work on the learning so far in that session. So we just take a little break. It'll be back next session, but today we'll leave it as it is. So we are moving into a big shape section now. We're going to start with our circles and our sectors. So you have a circle with two incredibly important parts, the radius and the diameter. We need to make sure that we are identifying in questions a radius and a diameter accurately, because if we're not, that's what's going to cause us the problems. So if you can remember the formulas and then you put the wrong thing in, obviously it's going wrong. So radius is half a diameter, or a diameter is twice a radius, okay? So they are connected in that way. You can see that the number pi is also written down for you to see. Pi is a number. It's programmed in to the calculator under this symbol, and it's used in area and circumference by using the symbol. Obviously, we want to use a symbol for such a complicated number, because who wants to use that every single time they're doing a piece of maths where it's needed? So pi just really helpfully holds this number for us, so we don't have to write it out every time. So that's what pi is. It's this number. That number is what we call an irrational number. If you look at it, I've done some of the decimal places, but I haven't done them all, because the number actually goes on and on and on into infinity. It doesn't terminate at any point. And there's no pattern at any point either. The numbers literally randomly come up. There's nothing that recurs. There is nothing that repeats. So we call that irrational. I want to just give you a little bit about why this number is so important, kind of how it's connected to circles. I'm not going to go into a deep investigation. I just want to give you enough background to appreciate why it's even there in our formulas, okay? So if we take a look at circles, okay, every single circle, be it small, be it larger or bigger still, every single circle has a circumference, okay? So out of the three that I have just drawn, that circumference is definitely smaller than that circumference and that circumference. And every circle has a diameter. So the diameter of this circle and this circle and this circle, they're all different lengths as well. But the lengths of the diameters and the circumference are connected. If I take the formula C equals pi d, and I just rearrange that so that pi is actually on its own, not C. So I pick up d, which is a times on this side, and I pop it over here, it lands as a divide. If I just tidy that up so I can see it better, I now have pi on its own equaling the circumference divided by the diameter. It doesn't matter what size circle you have. If you take the circumference and divide it by the diameter, you get that number. Every single circle gives us that number, which is why this number is so important and why it appears in our calculations, because of that relationship between the circumference and the diameter. So that's just a little bit of background understanding behind exactly why pi 3.14159 is so important, because it's connected in there through that circumference and diameter. Okay, let's get stuck in then. Let's actually start doing some maths. So if I've been given a circle, so let's draw us in a circle. And I'm also given this piece of information here. I could be asked to find the area, or I could be asked to find the circumference. Circumference is the edge all the way around. Okay, so let's do it. Let's find the area. So your first job is to recall the formula. Now, this isn't given to you in the exam. You really are going to need to commit this to memory. The best way to do that is to write it out every single time. It'll be tempting not to, because once you've done a couple of questions, you've written it out a couple of times, you can just look back at that question and know what you're doing. But write it, get that brain to start to form a memory of it. And the best way to do that is to write it every time. So I couldn't encourage that enough. So the area is pi r squared. That means pi times whatever the radius is. So you go to the diagram and you look to see what they've given you. They have given us a radius, so that's brilliant. I can just put that number straight in. Now, 4 squared is 16. So I could take the 16, squash it to pi. And that answer is an answer, the way that they describe it is they say it's in terms of pi. In terms of pi. And every now and again, you could see this question on a non-calculator paper asking for an answer in terms of pi, because it genuinely isn't that hard to do. You literally just stop after you've done a little bit of number work here. So it's just a way of the examining board to get this topic out of a calculator paper and into non-calculator. But it's quite rare. They are limited in how much they can do. So it's important to be aware of this, but we are going to work all the way through to our decimal. So here in your calculator, you would just press your S to D button, which would give you the final answer of 50 point, and we'll do it to 2 decimal places. Centimeters squared are our units. Okay, circumference. Circumference is pi d. So again, I know that I need a number to replace that letter D. I go to the diagram to get that information. The information I've got, however, isn't of a diameter, it's of a radius. Diameter is all the way along. So I need to double that radius to get the diameter. So it's going to be pi times 8, which is 8 pi, if I'm going to leave my answer in terms of pi, or all the way through in the calculator, and I've got 25.13, and that is to 2 decimal places. Units are centimeters, because it is just a length, okay? If I had a piece of string, which was in a straight line, and I measured it at 30 centimeters, you'd be very happy. That's a length of 30. If I take the same piece of string and then I just shape it into a circle, it's now a curve, but it's still length of 30. So we don't change the units for circumference. All right, let's do another one now for you to have a go at. So let's try this one next. So we've got the circle. We've got that given to us with 10 centimeters. So I want you to hit pause and just have a go at doing the area. Come back and hit play when you're ready. Okay, so my area is pi r squared. I go to the diagram because I would like a radius, but what I see is a full diameter. So I've got to remember to half that, which would give me 5. So I've got pi times 5 squared, which is 25 pi. Go all the way to the decimal, and I've got 78.54. That's to 2 decimal places. It's area, so centimeters squared. If you got that right, really, really well done. Hit pause now, have a go at the circumference, and play when you're ready. Okay, so circumference is pi d. I've got the diameter, it's 10, so pi times 10, which is 10 pi in terms of pi, or 31.42 to 2 decimal places, and it's centimeters. Okay. So this time I want you to just go for it all the way through, area and perimeter, and then press play once you've done both. So let's give you a circle. And we've got 16 going on there. So we'll say 16 centimeters. All right, hit pause and press play when you're ready. Okay, so area is pi r squared. So I want a radius from my diagram, which is what I've got. Perfect. So straight in with that number. Okay, that is going to give me 256 pi. That's in terms of pi, or the decimal 804.25 centimeters squared. My circumference is pi d. Obviously, I had a radius, which means I don't have the diameter. I need to double that, which is going to be 32. So pi times 32 is 32 pi in terms of pi, or 100.58 to 2 decimal places. All right, so if that went well, brilliant. We are going to move now from full circles. Obviously, you'll get to practice this more at the end, to this shape. Now, I'm going to be drawing this a little bit more by hand, so it will be a bit rubbish. There we go. So we're looking at a semicircle now, okay? And I'm going to give you the information of 28 centimeters. Now, I want you to have a go at finding the area of that before just watching me show you, okay? So we know what we know. How do we use what we've currently got? What's our current knowledge on circles? How do we use that to solve this question, okay? So I want you to hit pause and press play once you think you've gone as far as you can with that. Okay, so the area of a full circle, so the area of a full circle is my current knowledge, and that is pi r squared. Now, this is an important fact. The formulas for our circumference and our area are used for any question with a curve in it. The reason being, they're the only formulas we have that link to curves. So this question is going to use pi r squared because it's the only thing I have available to me with a curve. So pi r squared would get me the whole circle. I don't want the whole circle. I only want half the circle. So actually what I need to be doing is a half of pi r squared. Of in maths, remember, means times. So half of pi r squared means I now need a number for my radius. This line here, if it's a semicircle, is a diameter. Because a semicircle is half the full circle, the line going across will be the diameter. So the radius is half of that, which is 14. Oops, put the 4 in. 14 squared. Okay. So I'm doing a half of pi times 14 squared. I can literally throw that whole thing into my calculator, press S to D, and I get my answer of 307.88, correct, to 2 decimal places. Okay, so I'm still using the same formula, but I only want half of the result that that formula would give me. And the circumference, the perimeter of that shape, is going to work in pretty much the same way. So if that went a little bit wrong, it doesn't matter, because you know what, you were giving it a go, and that's all you really want to be doing when it's something that's new. Finding the perimeter of this shape is, again, something that's new. So you've got an idea now of how to approach it. So I want you to hit pause and press play when you are ready. Okay, so let's rub this out so it's not distracting us. So I want to find the perimeter of this shape, and this shape is half a circle. So the circumference, which is pi d, which is for the full circle, I actually only want half of it. So I'm going to be doing a half of, which is times pi, and the diameter is given to us as 28. So a half times pi 28 goes into my calculator, and I get out 43.982, and on it goes. But you haven't finished when you get to that number, which is where a lot of people do stop. So it's really, really common. So if that was your answer, you just haven't quite finished the perimeter, because what you've got here, remember, is half a circumference. So you've got that. That's what that number there is representing. If I want the full perimeter, then I've got to go all the way around the outside of the shape. So I need to add on that 28 in order to get the perimeter, the full perimeter of that shape, which comes out at 71.98 centimeters to 2 decimal places. If you remember to add the 28 in, then seriously, really, really good, because I can't tell you how common it is for students to just miss that and not kind of spot that step. Okay, we're moving on to sectors. We have actually, technically, you could argue, just worked on a sector. So let's think about the definition of a sector to start off with, okay? If I've got a circle, and I'll draw myself a little one here. If I've got, and I'm going to draw another one actually, because I want to do 2 different examples. If I've got a circle and I want to draw a sector from that circle, I have to go to its center, and I have a radius and another radius. And that there has created a sector. I'll try and color it in a little bit. It just won't look particularly pretty, I don't think. So that there, not too bad, is a sector. And it's made from 2 radiuses. So if I consider what we have literally just done here, okay, it is made from 2 radiuses. Because if I take this center point and go, right, there's a radius going in that direction, and there's a radius going in that direction, but I'm right in the center, I've also drawn a full diameter, haven't I? But this sector, made from 2 radiuses, or radii is the correct language, that makes my semicircle. So the way that we find the sector is we use a fraction of the full circumference or of the full area. In the case of a semicircle, it's a fraction of a half. In the case of a sector that looks more like a slice of a pie, we're going to use the degrees to help us. Now, technically, the degrees are here, but we are so familiar with the fraction half that we're going to use and see a half. But the half has come from the fact that angles on a straight line add up to 180 out of the full circle, 360, which goes on to create that half. So we are going to be using, let's say we had 40 degrees here, we would be using 40 out of the full 360. and it would be this fraction that would be used here. And that's the only difference between doing a semicircle and doing other sectors. So we'll do the one that I've kind of created over there. So we've got a sector, which I will draw in. Like I say, they won't be brilliant, but they're good enough. So this is my sector that I've been given of 40 degrees that I now need to find the area and the circumference of. If you think you've understood enough of what you have seen so far and would like to hit pause and just go for it, I would love that. Absolutely love it. If you're feeling a little less confident, then obviously just let it run. That's absolutely fine. But if you want to have a go, then press pause and please go for it. Okay, so I want to find the area of this sector. This area is a fraction of a full circle, which you can see here. So I'm going to do my fraction of means times pi r squared. Pi r squared. Oh, do you know, I've just realized I haven't given you a number. So there was absolutely no hope of you being able to have a go. Let's put a number on there, shall we? All right, we will put the number 8 on. Okay, so if you still want to have a go, I'm so sorry. If you still want to have a go, hit pause now and have a go. And I'll just keep going with where I've got to. Oh my God, what a nightmare. These things happen. Okay, so I want to find my radius, which is in the diagram. So I've got this fraction times by pi times by the radius, which is 8 squared. Okay, so I'm going to pop that into the calculator, and the calculator is going to give me 22.34, and that is centimeters squared. So that is the area of the sector of the shape that we can see. Now, if you are wondering whether or not it's worth cancelling this, I would say no. This is on a calculator paper. The calculator can handle the numbers. You don't need to simplify them for the calculator. So I wouldn't bother. Don't do anything in addition, just in case it causes an error and you end up going wrong. The less you have to put into the calculator, the better, really. All right, so that is the area. If you would like to have a go, now you've got all the information of finding the perimeter of that shape, then please hit pause and press play when you're ready. Okay, so the perimeter then. So the perimeter of this shape starts off by finding this arc length here, which is a fraction, 40 out of 360, a fraction of the circumference, which is pi times d. Now, I haven't gone straight to the number because I really want to just point out that, remember, the sector only gives us a radius. If you're someone that can easily get confused with the radiuses and the diameters, then it really makes sense to maybe draw this out. So if you've been given this, and I'll show you what I mean by redrawing. If you've been given this, you could go, okay, so I know that's come from a full circle. It's that much of it, which is 40. And I know that that bit there is 8. That would enable you to just extend that and visually see. It's the picture that helps you see, okay, the diameter therefore is 16, and you go in and you put that 16. So we've got 40 divided by 360 times pi times 16, okay, that will equal 5.585, on and on it goes. But remember, this number here is not the answer because it was literally just finding this arc here. So that is what that number represents, just the arc. I need to add on 8 plus another 8 so that I end up going all the way around the outside. And that gives me a final answer of 21.59. That's to 2 decimal places, centimeters. So sectors are pretty much area and circumference formulas with an added fraction. And that's it. I think the perimeters are slightly harder because you've got to remember to go all the way around and add in that extra step, which you don't need to think about with your area. All right, so I'd like you to have a go at a question now. So let's just draw you out another one. So we'll have, oh dear, oh, that worked. And then we'll stick on our curve. We're going to give this 32 degrees. We'll put 10 centimeters on the edge there. I'd like you to have a go at area and perimeter. If you wanted to do it one at a time and check in, then just let it play, but pause before I start talking about the perimeter. Otherwise, do both and then come back to me when you're ready. Okay, so the area is the fraction of the whole circle. Whole circle is pi r squared, so pi times radius is 10 squared. Put the whole thing in your calculator, you get 27.93 centimeters squared. Job done. Okay, so that is your area. Your perimeter is going to be the same fraction times by pi d, and remember, if that's 10, my diameter is going to be 20. I put that into my calculator. So that equals 5.585, and on it goes. But remember, that is just that part. I need to add in the two tens. So plus 10, and I have got a final answer of 25.59 centimeters. Okay, all right, so well done. That is all the examples that we're going to do. Your questions are there. You've obviously got them in the workbook. I'm going to scroll through slowly in case you're using the screen, and then I'll do the same with the answers, and then I will see you next session. So well done today. I'll get rid of me, and there we go.